Science for Dummies. This presentation will be given by Rémi Sabonnadière. Rémi is a data scientist specialized in data analysis, management, and visualization. He has experience working with both private companies and public institutions. Rémi got a bachelor degree in chemistry and chemical engineering from the EPFL and a master degree in business analytics from the Imperial College in London. So Rémi is working with us in the group Health Systems Data Science since March. And today he will present a brief history of data visualization and show how it may apply to medical research. So he will talk about existing tools that may be used for this purpose and illustrate this by a set of examples. Rémi, please.
Sorry, Mike. So thank you, everyone. I hope you can hear me properly. So it's the last session of this data science for dummy. I don't know it's the best for the last, but I will do my best. So as Valerie mentioned, today we're going to talk about what's data visualization, clarify a bit the slang, and then we will move on how to use it. And finally, we will go on a use case that I prepared based on COVID data to have a trendy subject. So we're going to talk about many topics today. We're going to ask ourselves, why should we visualize data? And most of you are already doing it on a daily basis. Why we should have both human and computer in the loop when it comes to dashboarding and visualization. Why also when you do research or when you analyze data, you should depend on your vision and your ability to detect trends. Then last and least, why show data in detail? And very important, why should we use interactivity? So we use data visualization every day, and the revolution has come from, I don't know if you remember, but when you move from drawing chart on the paper to Excel and starting to build graphs, you had a great increase of productivity. You were able to make new plots, new graphs, be more precise. And the same revolution has happened now with a new set of tools and technology. The same productivity increase is happening when you move from hands drawing to office tool and now from office tools to data visualization and dashboarding. And we'll understand why you can save so much time and be much more efficient. Does it sync? Yeah, okay, sorry about that. More effect when we talk about technology and technology isn't working. So data visualization, as you can see in the slide here, it's an integral part of data science. I'm sure my colleague talked to you about in the previous session about the machine learning, statistics. You also need the database knowledge, software engineering, domain knowledge, meaning that if you do data science for health, you need somehow some health knowledge or a doctor in the loop. And visualization is one of these key skills to have. It's also why you tend to have different profile of data scientists working on big projects, because it's super hard to excel at all this field. And to try to define visualization, it's a process that transforms data into interactive graphical representation for the purpose of exploration, confirmation, and presentation. And most of the time, people think of data visualization as only presentation, having nice set of graphs, having nice colors, but we will see that it is used at many places in the data science pipeline. If we have a nice little analogy of what a data science pipeline looks like in real life, when you go in corporates or big institutions, you have the data ingestion part. When you take the data, you clean it, you prepare it, you store it, and at a certain point, at a certain point, you start to model it and apply machine learning algorithm to try to predict. You do some quality and performance analysis, and then you kind of ship your outputs into a dashboard or an application. And what's highlighted in red are all the parts where you are using data visualization in the process of data science. So there are three ways of using data visualization. First, when a data scientist is given a new data set or some statistician,
they always start to explore the data set to see if there are some patterns they can identify, and it will guide them in knowing which kind of techniques or tools or what direction they want to go before starting to apply algorithm and start building the solution. It's also widely used in terms of confirmation. So what's confirmation is when you apply an algorithm, a prediction algorithm such as random tree or many others, at some point you want to know to what extent your algorithm works and what is your accuracy, what is the percentage of false positive, true negative, etc., etc. So data scientists used to use visualization a lot in the confirmation and validation process of an algorithm. And last but not least, reporting and dashboarding. You can have a tremendously well-done algorithm and excellent result, but if you are not able to communicate this result efficiently to your audience, it's not going to be used. I've seen tons and tons of this use case where data scientists have performed great analysis. It was super clear, super well done, but at some point the result, they gave the audience something too complex to understand. It's the exact same way where when you do when you want to convey a message in a report, you do a nice presentation, PowerPoint presentation, you try to make things visual, etc. So visualization is the same process. So again, in the left-hand side, I love this graph because it's kind of compute the performance of a computer with regard to one of a human. Computers are super great at data storage and being able to remember my own phone number, numerical calculation, searching and finding, while humans are great at cognition and extrapolation, common knowledge and creativity. And basically what you see, the logic, planning, diagnosis and prediction is everything we try to do in machine learning and AI, trying to find the compromise between performance and human and computer. And when you give a data set to a computer are done. They learn very quick, but there are things that they cannot see, that they cannot extrapolate. And only a human would say, okay, this I understand why there is this little cluster on the top and on the top right hand. It might be an error of data collection, or you can understand and visualize things that the computer will not see. We'll see a very speaking example later on. And also, our eyes, our ability to see is a great way to understand patterns and visualize very quickly and extrapolate very quickly when you see it. Very important, data visualization, not computer vision. Computer vision is the ability of a computer to process images and videos. Data visualization is when a human sees some data. And as I highlighted in red, in data science, insight is generated by the human, not the computer. There are some exceptions to that, of course, but in most cases, data science models are decision support for you, for human to take a decision, to be informed, and to have a quantitative enhanced decision making. There's an increasing need of using data science because the production of data is increasing at an exponential rate. You see here some data about that. Of course, smartphones are generating a lot of data, and so there's more and more sensors that are generating also more and more of data. So it's not now data visualization is not visualizing an Excel file of 200 lines, 4 columns. In the project, you are talking about millions of data points, each of them with 40 or 50 features. And again, this is not a so big data science project. I've seen billions of data points. So you need also a new set of tools because Excel will crash at, I think, 6 million data points if my memory is correct. So data sets are also becoming increasingly bigger, more and more complex. So the static PDF reporting won't work in many cases. So this is why we need basically computer. This is a very human process to visualize data and interpret some and highlight some insight, but you need computer in the loop for 4 big reasons. The scale, of course, you cannot do by hand or with Excel or basic office tools. You need the ability to drill down. When you have millions of data points with dozens of subpopulation over time, over years, etc., You cannot put that on a PDF, static PDF, or otherwise it would be a 200 meters by 50 meters chart. That of course is hard to print. Also, you can interact with the algorithm. We will see how a bit later. Efficiency, I don't know. I think all of us have done the same thing or again and again in different reports. They have to replot, etc. The ability to use new tools is also the ability to reproduce very quickly dashboard to have a central one from which you can extract something you need instead of working with a localized Excel file from which you need to do a chart. You need to screenshot this chart and put it in the report. It's very tedious work and a lot of time. Quality, of course, we will see that you can have very good looking graphs. Beautifulness is not the only thing about data science, but something that looks nice is always good. And of course, storytelling. Given that you have interactivity, you can produce a lot of graphs. You can really walk through your audience some results and make it much more interesting for them also. So you basically save a lot of time and you also improve your analysis quality. So why show data and data? Why show data in details and what the ability to drill down? This is a very famous example, which is over 4 years old now, a bit less, and it was basically 4 different data sets that you can see on the left that have the exact same mean, variance, correlation, and linear regression line. So if you give that to a computer, it will say this is 4 times the same data set. I mean, it will not say, okay, these are different data sets, so let's understand why they have the exact same features, but there are 4 different measures, and it can, if you don't visualize at some point, the computer will go straight to a wall and consider it as the 4 same data set, and most likely you will take a wall at some point in your analysis. So this is why data scientists tend to always start with visualizing the data at the very beginning, just to make sure that this is not encountered, or there's other example where a computer cannot see what would seem obvious to us. Again, keep in mind that computers are dumb but learn quite fast. So unfortunately, in an hour, I cannot deep dive the world of data visualization. It's really an expertise. A lot of people study years and for years in data visualization before being able to do a professional level. But you see in this chart that you have 4 types of graphs: comparison, relationship, composition, and distribution. And then depending on whether you have categorical data, quantitative data, how many variables of the machine has started. Good. Thanks, Valérie. So depending on how many data, category of data, quantitative, qualitative, numerical, you see that you have approximately 20 type of graphs that you can do, and this does not include the maps, networks, and many more. So it's not about just using a graph, putting some X and Y measures and then visualizing it. It's really, there is a lot of expertise, and depending on if your data is cyclical or not, if you time series. I will also send you slides because this is a very useful one that I think can be used as of tomorrow, this afternoon, when you start to make graphs, especially for research. And again, this is fairly approved by everyone that it's one step. And again, there is many more. So I wouldn't have time to explain why I went to use a scatter chart rather than a stack column chart. But again, this design it has been designed to make the best chart for the best messages, to be able to see a difference or not. Again, but now you've seen it in black and white, but you can play with colors, with saturation, with brightness, with the hue, depending on what you want to convey as a message. We can see here that the combination, that if you change the shape of your data point and the colors, the message is not readable. There is spatial data, maps, graph entries, time-dependent, textual. So again, a lot of expertise is needed and experience to properly visualize complex data sets. accessible to many people. I've seen it plenty of time, but again, it's not just a matter of plotting point on a chart and say it's good from there. Again, you can see here that the number of parameters to take under consideration to build a complex dashboard is huge. So try to not move forward and just put the chart there and there, because we will see that it can have also bad consequences. Also, I'm sure my colleague have mentioned data quality as a big challenge in data science, but in data visualization, we need to take a lot of consideration also at the data structure level. Do you have real-time data, static data? Is that a certain or uncertain structure, unstructured, and the volume? So these are also in terms of data management a great consideration to make before starting. Again, if you want to visualize 200 rows on an Excel file, you don't need that. But if you want to monitor, I don't know, a live situation of the COVID or the flow rate in a pipeline, it comes quite complex problem. A very common trap in data science, and you can say in marketing and communication as usual, but it's a bias. You can very easily convey a message that is wrong by taking this bias. There is two main bias in the data visualization: the sampling. So I have a big sample of data, but I only will show the one that I want, or it can be voluntary or involuntary. And the confirmation bias, which is, to my opinion, one of the most dangerous, is I think, for example, a quite common example is it was used, the images were used to detect early warning signal of cancer, of brain cancer, and the doctors at some point were needed to collect the data and annotate this X-ray file. And basically, one of the doctors has his own belief about how cancer should be early detected, and collected the data based on his own belief. So I will give you two examples on how I can manipulate exact measure to just convey the message I want to convey. So kind of, we see that often in advertising about number of calories in a yogurt, for example, is on my right-hand side, I have the exact, for example, let's say it's a number of sales of someone. On the right-hand side, it's fair because you visualize that from 0 to 100, a certain growth. On the left-hand side, what often happens is, okay, I think my boss wanted me to have 50% increase year on year, but I'm only 22. So basically, I'm going to cut the bottom side of my graph, and he or she will see a great jump. But for the exact same data, I think it was 83 and 102. But this is very used at co-incorporate about sales when you want to convey, you want to show that you've been great from year on year, and basically it's not lying because you are allowed to do that. You are allowed to scale your y-axis, for example, but hiding and not putting the exact scale can be difficult. Same on the top side. On the green line is me, it's my sales as Rémi. And the red one is my neighbors, which has been better than me because the line is systematically above mine. But if I put mine in green and his or her in red, naturally, as human being, or especially in Western Europe or with the Western world, green is good, red is bad. So by plotting again the exact measures and the exact data, I can infer a bias into the brain of my audience that say, green is better than red, so Rémi is almost as good salesman as Thibault, the other salesman. Same can happen with the brightness of the line. You can also play on that. These are very basic example, and I can find much more speaking example, but this is very just to tell you that some information is implanted in our brain. Green is better than red, and you have a ton of cultural stuff that you're bright, something which is bright is better than dark, etc., etc. So to be very careful, sorry for the typo. So to be very careful about how you have duty of integrity and on displaying the information rightfully, not only the exactitude of the measure, but also how you can put it on that. Oh, we're moving quite quickly. Why use interactivity? So that is, I think, the main highlight of this workshop is there are limitations with PDF, with 2D, with a two-dimension view. Single static can only show one aspect. And not to mention, I remember when I studied at Unisanté, a report on COVID. I think it was vaccination, and it was just the number of no, it was test. And it was basically the chart of the number of tests, positive tests performed the last 7 days, the last 10 weeks, by month since the beginning of the year, and quarter by quarter, etc., etc. And each of them, given that it's hard to read, there was also the table with the data plotted behind. So to monitor a very simple data set, if you want people to really read the information, you need at least 10 charts for people to be able to read. I'm just going to share something up. And basically, this 10 chart could be replaced as one interactive chart. For example, here I've plotted I've used the exact same data, but basically I made it interactive. So if someone wants to see the exact number of positive tests on a specific day, on November 22, 2020, you can read it, 461. If you have a PDF one, you need a rule to be, and you would do a guess, it's between 450 and 470. You will not have the exact number, except if you go into the chart, which are basically pages and pages of data point. Then if I want to see, okay, now I have per day, but I want to have an analysis by months. You click a button and you have your analysis by months. On the PDF one, it will be another chart because you don't want to add up every day of a specific month with the calculator and have your information. If you want to do by here, you drill up, and you have a quarter by quarter. You want to go back by day, you do that. You want to have a zoom on, I don't know, October 2020, because it was the beginning of a huge wave. You can just basically zoom in and be able to maybe find a very specific insight. We can see here seasonality, where I imagine these points are weekends where less tests are performed. If you want to really go deeper, you can also play with that. But again, each time I touch my screen, imagine that on a PDF report, it would be a new set of charts by default. So the same data set, at least 10 graphs can be replaced by one interactive one. So if I go back to my slides quickly, do you see it now? Or no, I need to stop sharing and reshare. So now imagine we want to perform the same analysis of positive COVID tests with the gender of the people tested, the location of the test, compare with hospital vaccination, which kind of vaccine, which kind of test. You would end up with dozens, not to say hundreds of reporting. People managing the crisis will have a huge deck of reports, where to find the information. It's long, it's tedious. When you have interactivity in your dashboard, you can really make something simple when people can go directly to the information that is of interest to them, and also deep dive. So the key principle again on data visualization, data viz for the familiar with the topic, is not just about formatting and having a pie chart and nice colors that fits the company graphic line. It's very important when you go to serious data science project. It's super important to invest time and in data visualization. What I've seen a lot of time is people get excited by data visualization and they put a lot of features on the graph, and it becomes unreadable because basically there's too much information and the brain can process. So we have to keep it really simple, think about the user, and avoid what we call data junk, on which are the number of features you put on the graph. Fancy does not mean efficient. So you've seen on the often in the journal, on some reports, what we call infographics. So this is kind of
using data to make graphical art and have a very nice, fancy and colorful graph is not data visualization. These are very close, of course, but you don't need to do something fancy. You need to do something first efficient, and then if you can make it nice looking, this is a nice to have. Very important as well, when you build a visualization, most of the time you don't build it for yourself, except for the exploratory data visualization. You basically build this graph to communicate a message, to convey a message to a specific audience. So you should put yourself into the shoes of this audience and say, okay, what my audience need to see, who are my audience, do I have multiple audience, and most of the time you do a cahier des charges, like most of IT project, to know exactly who should know what. Use interactivity, of course, and be careful with bias. Now, you've seen a nice, fancy graph, interactive one, and you're probably asking yourself, yeah, but I'm not a programmer. I'm a biologist. I'm a public health professional. This is not for me. And even for programmers, you should know that coding from scratch an interactive graph can be tedious in old language data or Python and very time consuming. Basically, a computer, you need to specify the position of the chart. You need to specify the color of the title. Find the hosting, identity and access management can be very complex and unsecure. And for example, you have a graph on the right-hand side, which is nice and interactive, but it's more than 100 lines of code to produce that, so that's long. So I would not advise to code by yourself this, and good news for everyone, there are great tools that enable anyone without programming knowledge to develop interactive graph. So I'm going to do a little survey. I presented you a dashboard that basically plots the number of positive tests with regard to time, an interactive one. So I could share it with Valérie. I could share it to everyone. So to your opinion, how long did it took me to build this dashboard? Do you think it's more 2 minutes, 30 minutes, an hour, or half day? I'm going to let everyone make their own guess. And the result is literally 2 minutes. It's super quick with the latest tool to build interactive dashboard. You can go super quick and build interactive things. So don't waste time learning to code in R or Python interactive dashboard. It's really painful and painful and long. And the goal is to always gain time, gain productivity. So there are two very affordable ones that enable to go at speed light when it comes to data visualization. And there are hundreds of tools available on the market for data visualization, but there are two main leaders, Microsoft Power BI, which is kind of the child of PowerPoint and Excel to build a dashboard, and we will do a live example with this one, and Tableau owned by Salesforce. And these are the two main tools that are used for data visualization at corporate and institution level to build that. We're gonna talk about that, and again, my door is open if you have project on your own and you want to decide. They are all good. I mean, each one has pros and cons, but basically these are great tools to build what you want. And basically, sorry, it's in French, how these tools are used at corporate framework. You have your databases. The connectors are what basically enable a database to communicate with a dashboard, but all of that is automated. And these tools enable you to import data, clean data, analyzing data, and build a dashboard. And we will build one together right after. Then you have your distribution. You should consider whether it's internal distribution because it's sensitive data or public information. You want everyone to access it. And then there is tons of way to distribute the information to an audience. It can be through mail, through reports, etc., etc. If you want to know more, there are great books. So one I like most is by Andy Kirk. a successful design process data visualization. You have a lot of online courses. There's one which is advanced and long, 450 hours, which is called Applied Data Science, Communication and Visualization, which I had the chance to co-author when I worked at EPFL. You can have plenty of courses, a short one on Coursera, DataCamp, and Power BI and Tableau. All the provider basically also for free give courses on how to use these tools. Now we will build a live dashboard together. We are pretty much in advance to what I scheduled. So please feel free to ask questions at the end. So you might think, yeah, he told us that it took 2 minutes to build a dashboard before. I don't buy it. I wanna check. So I'm gonna prove I'm not a liar. And because Valérie asked me for in 15 minutes to build an interactive dashboard monitoring the tests of COVID in Geneva and Lausanne, because she wants to be able to present these results to the Confederation or whoever need that. So I'm gonna do it right now. So for what's my data set? I have basically the dates of each test, the location, whether Geneva or Lausanne, the outcome, was it positive or negative, and basically the number of tests, or it's in German, I took it from the Confederation website, and basically the number of tests. So plotting a map is very difficult if you want to do it by hand with R, Python, or Stata. Geocoding is quite complex, but thanks to this tool, so this one is Power BI, what I need to do is to set the location is my location, and the number of tests, the size of the bubble. Yeah.
The location, what information you have?
Geneva or Lausanne. Yeah. And then, of course, you can have, imagine all kind of info. Street addresses you can monitor at country level, so we are red at Unisanté, up. And I think my bubble is a bit small, so I want it bigger. So literally 30 seconds to have this interactive map where I can zoom in, I can play with it. We could have indeed street addresses, deep dive, do by county, etc. And again, if you want to do it using Excel or R or Python, this is very long. This is tedious work. You need to encode geographically the right address. This kind of tools automatically detect that Lausanne is Lausanne in numeral languages. And basically this only, I think with Microsoft is TomTom, which still exists, surprisingly, and Bing. And basically you can very quickly build something that I want also to be able to zoom in, zoom out. So it has a button to be able to zoom in or zoom out from your map. So you can also explore the entire Switzerland or at world level to see that. I want also to have on this graph, I want to split here what are positive tests and negative tests. So this is done again by just plotting. What I want to add as well is evolution, temporal evolution of the number of COVID tests. So I'm just adding, values, the number of tests here, and it will give me the graph I want to see by day. I go very, very deep indeed. I want again, Unisanté, we are red team, so I put myself in red, up. And what I also want is to see not only at Geneva and in Lausanne, how many tests were positive and how many were negative. So here I take pie chart, I do the outcome test as a legend, I add the values, and good news here is, for example, when you take interactivity into account, I want to only see the data in Lausanne that are negative. If I click here, the graph here has changed. I'm going to take a small one, and automatically you can zoom on the data you want. Again, for that you want to do a static reporting of that, tons and tons of graph. And good news is you can also. I want a slicer because I want sometimes to have only the data for Lausanne. Up, I click Lausanne. It will only show me the data for Lausanne. Oh, sorry. I want only Geneva. It will show me only Geneva very quickly. Again, I don't know. Valérie wants to know for what happened in the last 2 weeks. So I'm going to build another slicer. I'm going to ask it to be, sorry, without a mouse, it's difficult. Relative date, I want the last month's calendar, so it's September, so it's going to be August. And if I click here, it's gonna show me only the data of the last months in Lausanne, and I want to have it here. And here it goes. You have your interactive dashboard, but again, you want to still have the table with all the data. So I'm going to add that. It's going to show me, sorry, up here. I want by outcome here, because I want to be able to check every data. So I'm going to tell him, okay, deploy all. And basically, you're going to have all your information. And yeah, I want also to add in a column by year, the exact number. So I put column here. And I clean this. And you have all your data. So literally, I started at 32. It's now 39. And this is ready to use and to deploy and to control the access of who can log in on this very dashboard. And it's done. I think it can be used already with a data set I took from the Confederation. It took 7 minutes to build it. So you can go very quick. These tools, you can have also automated machine learning for anomaly detection. You can put graph, you can put, basically so these are default charts that I've put in. But this tool, and again, Tableau is more or less the same. These advanced tools. You have World Cloud, you have hundreds of pre-made charts that you can use for almost anything, heat map. Yeah, I mean, I've never really encountered a situation where I couldn't that couldn't be solved using that. You can also integrate R script and Python script if you really want to visualize something very, very special. And turns out that you cannot do it with Power BI. You can still build from scratch a Python script. And now I'm going to save it. And we still want to have a PDF file, so I export it to PDF. And now we're going to see what it looks like, PDF versus static versus interactive. It always takes sometimes. But here we've seen that the rapidity, and of course I'm very familiar with this tool, so it goes fairly quick. But again, I think you take the 101 Microsoft Power BI course, which I think it's 10 hours, and you will be able to do 80% of the features of Power BI very quickly. And you can already share research output, explore data on your own with this, and it's part of the Microsoft suite. For personal use, it's free. If you want to use it and share interactive dashboard online, it's 10 Swiss francs per month, so it's quite okay. So these are not 1,000. It's not MATLAB. It's okay. So now I have my static version, and if Valérie asks me, okay, show me the data for Lausanne, that's a bit less speaking. You cannot zoom in. You cannot see the graph here. I want to see in January 2021. I have to sum up all these points to have the data only for January. So I would need to export dozens and dozens of static files for Valérie to be able to access the information and the measures at the right time, and not saying, okay, where is that in my second in my file. So that's it for me. I think the goal of this workshop presentation was more to attract your curiosity, have you asking more questions that you had before. Maybe, yeah. Again, I'm working 30% for Unisanté because I have my own company on the side. But I'm more than happy to book to take 1 hour and discuss your specific research. Do you need this dashboard, or do you or you don't? Which is the best solution? We've done some pretty quick proof of concept also with Valérie on geomapping some articles or monitoring X or Y data. So it's pretty quick. You see that if you give me a clean data set, I can literally in 10 minutes give you the first results, and then see if it was making it a project or invest or add new data, because also it's great to do what you when you have a data set, you have your own what you know you want to visualize, etc. But you, with this interactivity, you will see that a new world is opening up in terms of what you can explore, what you can share with data. So my door is my virtual door and the real one are more than open to discuss this subject. So now, if you have questions or comments, I'm more than happy to answer.
Thank you very much, Rémi. So I don't see any question on the chat for now. I have just a question regarding the different dashboards. Are there some, I would not say limitations, but advantages by using one versus the other, or do you know about some differences?
Well, when you ask a data scientist which one is the best, it's almost a religious debate, because everyone has his own preferences. Myself, I prefer Power BI because it's much more easier to use. It's part of a Microsoft tool, so we are all familiar with Excel, for example. It's the same programming language. When you need to do a calculation, calculate, I don't know, average per month, it's the same equal sum average than Excel, so it's much more speaking to someone new to the field. It's less expensive than Tableau, but again, both tools, I have objectivity duty. Both tools are great, but definitely for someone new, I would recommend Power BI as a tool. Again, part of Microsoft Suite, interactive with Excel, PowerPoint, of course, can be embedded on the SharePoint. Also, what is a key difference in terms of organization is it uses your own Outlook email address. Unisanté, it's behind its Outlook. So getting access, it's much more simpler for the IT team to manage the IT park with Power BI rather than Tableau, because by default, Power BI, you will have your own Unisanté address already embedded into it. And it's not a new, well, it's part of the Microsoft Suite. So it's going to be the same Outlook account than you already have. So also for the guy working on IT, it's a simpler choice. But again, both are great. I'm myself biased, so I'm trying not to communicate this bias, but definitely Power BI.
There's some question here. So I think we should all put into practice with one of our data sets how we can visualize easily some results on such kind of dashboards. Just another question on the location. So here you use something which is proposed directly by Power BI.
Yes.
I mean, for example, if I don't want to have so many details on the map, so are there some possibilities to have maps with different kinds of details?
Absolutely, and I'm getting asked this question a lot. In general, you can do almost anything in terms of. So I don't remember exactly where it is to change it. Map style. So I want to not show the label, and I want an aerial visualization, and there it's done.
Yeah.
So you can change almost anything, maybe a very small thing, I don't know, you cannot make the P of positive bigger than the O. That's a shame, but in terms of practical change, you can almost change everything, and in a matter of minutes. And again, if you want to program that from scratch in Stata, Python, or R, this one, I would say, to make it robust, it's 1 day or two for someone good at programming. So save yourself sometimes 10 francs per month is, I think, a good investment with regard to your time.
Okay, thank you very much. Yes.
How about you?
You know, if you have access to the world line to software.
Yes, it's all.
Work at Unisanté. Sure.
You can download.
You can download the free version for your own use, but we are discussing if there is a need to have also this ability to share.
And then when you have the license, you are able to share HTML.
Yes,
What did it
you
say?
can share many prospects. People will be able to use it and to be interactive with it if it's public. But for example, if you want to have a kind of confidential data, the other user should have a license as well. So this is where they are smart because most of the data are sensitive. So if you want to have a working group of 4 people and you want to everyone be able to share the dashboard, contribute to it, and use it, these people should have a license.
Otherwise, you can share the file.
Yes, you can share the file.
Using the dashboard, but of course, this means that if somebody makes changing or change something, then you will not have the updated file.
Yeah, but the thing is, sharing online is because you can also monitor who has it, and you will not have all these features, etc. It's going to be much cleaner. So it's going to be this. Yes, save up. It's going to be people will basically be able to interact with that directly, and if you want the export, they will be able 1, 2, 3. They will be able to export the data, etc. So there are ways not to pay the license, but for full use and professional use, I recommend. But you can have one license by department, for example, and you basically use it analytics at DESS at unisanté.ch, and everyone. It's required to work with someone remote on that to connect on this new license.
So there is a question from
Yes.
the next panel. How about choosing the best type of graph for a given data set? Do we know some guidance or learning tools?
I can share the graph that I presented here and learning material, but I will also share the lecture I have from Imperial on that. It's a lot of experience. There are good practice, but basically the best way of doing is of learning is by doing. But there are some very precise rule if you use dates and if you have quantitative or qualitative data, and then whether it's the pie chart. I will share the slides, and there is one slide about exactly when to use which one, and it's strongly advised to follow this procedure.
And there is also the reference of this.
Yes.
figure. Yeah.
Yes.
Thank you. So no other questions. So again, I thank you very much.
Thank you.
For me, this was very interesting, practical presentation.
I try to.
And this will also close our workshop. So thanks for those who were present at any of the sessions. And I wish you a good afternoon.
A pleasant flight. Thank you.